Today we're looking at function operations in composition, and now we're going to take a look at multiply and divide functions. Let the function f of x equal 3x, and let the function g of x equal x to the 1/5. Find the function composition for the following function operations, then evaluate the product and the quotient for the given x value. A note there: you cannot always determine the domain of the composition from its equation. And so we have multiplication here. So we have f of g, or f times g of x. So the function f is 3x. And we're going to multiply that by x to the 1/5. And when we have the same base, in this case our base is x, we can add the exponents. So we'll end up with 3x, and then this is a 1 here. So really we could write that as 5/5. That's the same way of writing 1 plus 1/5. And so in this case, we get 3x to the 6/5. Now, we have to pay attention here because we have a fifth root. So whenever we have a radical, we have to decide if that limits our domain or not. So another way that we can write this is we can write this as 3/5 root of x to the 6th. Now, because this is an odd integer, this does not limit what happens underneath the radical. We can have negative values under the radical, so that's fine. So this doesn't limit our domain. This function doesn't limit our domain. This function doesn't limit our domain. So in this case, the domain is going to be all real numbers, or we can write an interval notation, -infinity to infinity. If we look at f divided by g of x, we're going to do the same thing. We're going to take the f function, which in this case is 3x, and we're going to divide it by the g function, which in this case is x to the 1/5. So right away, because we have division, we know that in the denominator, our domain is limited right here. X cannot equal 0. So we know that already, because we cannot substitute 0 in here and have anything divided by 0. That doesn't work. We have the same base. We have x and x, so we can subtract those. So we can rewrite this as 3x, and this is x to the first. We can write it as x to the 5/5 minus 1/5. And then we're going to end up with 3x to the 4/5. So this doesn't limit our domain again because we have odd integer that's on the radical, so that doesn't limit our domain. So basically the only place that our domain can't be is our domain can't be equal to 0. So we can say the domain can be the set of all x values that belong to the real numbers such that x does not equal 0. Or we can write it in interval notation negative infinity to 0, 0 is not included, union 0, where 0 is not included, to infinity. So then we go down to C and D here, and we have already calculated what the function f of g, or f times g, is, and now we're just going to substitute in 32. So we've already calculated that 3 times x to the 6/5, and then we're going to put 32 inside the parentheses here. Three to the 5th root of 32. The 5th root of 32 is 2. And 2 to the 6th is 64. And 3 times 64 is equal to 192. And then we've already figured out what f divided by g of x is. That's 3x to the 4/5. And we're going to substitute 1 in. The 5th root of 1 is 1. 1 to the 4th power is 1. So we're going to end up with 3 times 1, which in this case is equal to 3.